So this is a Simplex method question from D2 Edexcel 2010. First question is to write down the profit equation. Each one of these is actually an equation. For example, this one is y plus 2z plus r equals 24. So the table, or tableau, is just a convenient way of writing a load of equations, and it actually simplifies things. Students think it doesn't, and they prefer to write equations, but all I can say is try and do it, and you'll see that it does simplify the matter. The profit equation, slightly different to the other ones, because you have to make sure you've got a p at the front. So it's p minus x minus 2y minus 6z equals 0. Okay, so now it's telling us what to do. It's saying taking the most negative number in the profit row to indicate the pivot column at each stage, solve the linear programming. So this is going to be, first of all, this is not optimum. We can see that because we've got a load of negatives here. If we can get a profit equation with all positives or no negatives, to be more precise, because it can be 0, then we've got an optimum solution. But here we've got lots of negatives, so it's definitely not optimum. So for our pivot, we're going to start trying to do our rearranging with. We pick the most negative, which is minus 6. To get the appropriate cell, we work out what's called the theta value. So we've got theta is 24 divided by 2. So 24 divided 2 equals 12. And the theta value corresponding to this row is 28 divided by 4. So that's 28 divided by 4 equals 7. And the theta for this value is 22 divided by 3, which is 7 1/3. And we're picking the least one, but it cannot be negative. We should never choose a negative pivot. Cannot stress that enough. It got to be positive, but then the least theta value. So that's our pivot. Okay, so now our aim is to basically get that number to rearrange, and to make it simpler, we change that pivot row so that that number becomes 1. So basically we're going to divide by 4. R2 divided by 4. Let's swap out the basic variable bit here, because that's the thing we're working with. So S now swaps to Z. Don't forget to change a basic variable. And we can divide all of them by 4. So that makes that a half, this a quarter, this number 0, this a quarter, 0, and 7. Okay, so there we go. So we've got that's our pivot row sorted. Now we need to get the other ones sorted. So let's just do this one first. The first thing we're doing here, let's get the row operator for this column. We need to get these numbers to 0. And I note that the number here was 2. So we need to do the R1, which is the old R1, take away 2 times the pivot row, the new R2. So that's our row operator. And we've got to do that for each one of them. So for example, this number here, number in this cell, has got to be 0, take away 2 times the number in this cell here. So 0, take away 2 times a half, which is minus 1. Okay, so that is minus 1. Then we can do the same for this number here. 1, take away 2 times a quarter. So that number there is equal to a half. Okay, so this number here has got to be 0 by definition. We've chosen our row operator. Basically 2 take away 2 times 1 is 0. We've made it that way. This number here has got to be equal to the old R1 take away 2 times 0, but we've got a 0 in that column, so that number's unchanged. Okay, this number here is equal to the 0 take away 2 times a quarter. So that equals to minus a half. And this number here is equal to 0, and we've got 0 here as well. So 0 take away 2 times 0, which is equal to 0. And then this number here is equal to the old 24 here, take away 2 times 7. So that number there is equal to 24 take 2 times 7, so that makes it 10. Okay, let's work out the row operator for this one. I note we've got 3 here, so we want to do R3, that's the old R3, take away 3 times R2, which is our pivot row, so it's the new R2. Okay, to make that number 0. Okay, so we're always aiming to make our pivot column in the new bits equal to 0. Right, so this wasn't our pivot row, so the basic variable's unchanged. Right, so this number here is equal to the old R3 minus 1, take away 3 times this number here. So that equals to minus 5 over 2. Okay. This number here is equal to a half, take away 3 times this number here. So it's half take away 3 times a quarter, which is minus a quarter. Okay, let's say the pivot column's already been sorted. So this number here is equal to the old number in the column there, R0. Take away 3 times this number here, which is that happens to be 0, so that's still 0. Okay, this number here is equal to the old R3, which is 0. Take away 3 times a quarter. So that makes that minus 3/4. This number here is equal to the old number here, 1. Take away 3 times 0. So that's unchanged, that equals 1. Do take care with this. You can get sorted with the numbers, use a calculator, find a way of being accurate with these numbers, because some people are better at this kind of level of accuracy than others, but as often as not people lose marks for lack of accuracy rather than actually not understand what they should be doing. Right, so this number here is equal to the old number from the table before, 22. Take away 3 times 21. Well, 3 times 7, which is 21. So 22 take away 21, which is 1. Okay, so one more row for this time. Profit row. Right, well, we had a minus 6. So we want to be getting this number to 0, so we need to add 6 from the pivot row. So that makes R4 plus 6 times the pivot row R2, the new R2. Okay, the P never changes, let's always stop there. Okay, so, right, so this number here is equal to the old minus 1 there, plus 6 times this number here. Be careful, that number should come to 2. Okay, so it's minus 1 plus 6 times that, which is equal to 2. Okay, so then this number here is equal to the minus 2 here plus 6 times minus a quarter. And that number equals to minus a half. Just as apologies, the number here was correct, but of course it was the half I was working with. So going back to that one, it should have been equal to the it should have been equal to the old number in this number minus 1 plus 6 times a half, which equals to 2. For that reason, just because I made a mistake in the column there, it's worth sometimes maybe, because this is our pivot row, maybe worth actually highlighting it so you don't end up taking the wrong number, which is what I did. I had the number written down where it should be, but which is why I ended up with the 2. But it may be worth doing that just to check that, so that we're always referring back to our pivot row. Okay, so let's get on with this now. We've got this number here is equal to the old 0. Okay, the old number from there, take away plus 6 times 0, which is 0. Okay, fine. And then this number here, that number there is equal to, again it was 0, plus 6 times minus 6 times a quarter. Okay, so that's 6 times a quarter is equal to 1.5 or 3 over 2, and because the old number was 0. And then this number here is equal to the number here is equal to the 0 here, but we've also got 0 in our pivot row, so that's still going to be equal to 0. 0 plus 6 times 0 is 0. And finally, the number in our value column is 0 plus 6 times 7, which is 42. Okay, so that's the first iteration done. Right, okay, let's, now we've got a lot of fractions, so it's going to be a bit tricky. Let's just get this sorted and get on with it. All right, okay, now, first of all, this is going to be, it's not optimum because this is minus a half. To pick our theta value, obviously it's not this because that would be a negative pivot, so that's not on. So we've got 10 divided by a half, which is 20, or 7 divided by a quarter, which is equal to 28. We're picking the most, the least, but it can't be negative, hence we're not doing the next column. So that means that this is our pivot row. Okay, so our row operator, we can double it or talk about dividing by half. So we can say R1 divided by a half, or R1 times 2, take your pick, is our row operator. Okay, so timesing this by 2. Let's make sure we swap out our basic variable as well. So we've got Y instead of a swap for the R. The others are obviously unchanged. Times everything by 2, so that makes that minus 2, 1, 0, 2, minus 1, 0, and 20. Okay, so again, I think to try and avoid the error I made here, which wasn't a deliberate error, it's just easy to look at the wrong numbers. So there we go. I'm going to actually highlight the pivot row as well, just so that, well, I'm always know that I'm taking away numbers from that or adding numbers from that row. Okay, so let's look at what we need for the row operator. Well, we've got the number in this column here, this row here, we've got equal to a quarter. So we need to make sure, we need to get that to 0, so we need to take away a quarter. So this number here will be equal to R2, which is our old R2, take away a quarter, R1, our pivot column, the new R1. Okay. So we need to follow that through for each of these numbers. So, for example, this number here is going to be equal to the number minus is equal to the number a half from before. Take away a quarter of 2. So a quarter of 2 is equal to a half. Minus a half, and we're taking that away, so it's like adding it, so that makes that number equal to 1. And we do this for each one of these. So this number here is going to be equal to the 1 from before. Take away a quarter times 0, so that's number still 1. Okay. And this number here is equal to the 0 from before. Take away a quarter times minus 2. Take away a quarter times 2. So that makes that number equal to minus a half. Quarter times 2 is a half, and we're taking that away. This number would be equal to a half because we've got a quarter. Take away a quarter, but take away negative a quarter, which is plus in a quarter, so that makes it equal to a half. This number here is the old number 0 there, but we've got a 0 in our pivot row anyway, so that's still 0. And then the number in the value column is equal to our old value, which is 7. Take away a quarter of the value from the pivot row, which is 5. So it's 7. Take away 5. That equals to 2. Okay. Right. Now, the next row number we need to remember our pivot. Probably should have pointed out where my pivot was. That was equal to the half from before, so this is like our pivot here. So that's our pivot. We want this to be 0, but it was minus a quarter before, so we need to add on a quarter. So that's our R3 from before, the row, plus a quarter times by R1, our pivot. Well, let's write that properly so that we can see it. Quarter R1. Right, okay, so let's just do this. Oh, the numbers are getting, say, use a calculator or whatever. I'm doing these in my head, but it is, just find a way of doing it. I think with the fractions and everything, just have a system and be careful. Now, here, this number here is equal to the minus 5 over 2 from before, plus a quarter times minus 2. That actually makes that number equal to minus 3. Okay. Then this number here is equal to the 0 from before, but we've got 0 in here before anyway, so that's still 0. This number here is equal to the 0 from here, from before, plus a quarter times 2. Quarter times 2 is half, so this number here is equal to half. Right, now the number here is equal to the minus 3 quarters, minus 3 quarters plus a quarter times minus 1. That makes that number equal to minus 1. And this number here is equal to the 1, but from before, plus a quarter times 0, which is still 1. And now the number in the value column is equal to 1 from before here, plus a quarter times 20. A quarter times 20 is 5, so that's 1 plus 5, which is 6. We're nearly there, just one more row to do. Okay, so here this row is, we need to remember our pivot was this column here. So we need to make that 0, but it was minus half from before. So we need to do R4 plus a half times R1, our pivot column. That's the old R4 plus half times the new R1, which is our pivot column. Okay, so this number here is equal to 2 plus a half times minus 2, and that equals to 1, because basically 2 minus 1, 2. This number here is equal to 0, and there's a 0 here, so this number is still 0. Okay, this number here is equal to 0 plus a half times 2, so that number is equal to 1. And this number here is equal to 3 over 2 plus a half times minus 1. So that's basically 3 over 2 minus a half, so that's equal to 1. Okay, now this number here is equal to the old number 0 plus a half times 1. No, not 1. Here we go again. Half times 0. So that's 0. And then this number here, finally nearly there, is equal to 42 plus a half times 20, that's equal to 52. Mercifully, it'd be rare to have a question where you have to do this 3 times. It's all positive, so this is optimum. I don't think they've asked us to explain, but this is optimum because no negatives in profit row. The equation, it hasn't asked for the equation either, I don't think. Let's have a look. It's taken such a long time, I've forgotten what the question was. It says make your method clear by stating the row operators you use. We've done that. It hasn't asked for the profit equation, but you know what, I'm going to write it because other questions do. P plus X plus R plus 1 equals 52. Now we can see that if we increase R, not plus 1, plus S equals 52. If we increase X, R or S, then we would decrease P. So this is optimum. So there's no negatives in that row. We've not been asked for that in this case, but just in case in another question. So it is optimum. So that's our equation, and it says state the final value of the objective function and each variable. So that means each variable. This is for the final part for part C. Done all the hard work here. So we're reading across. P is 52. Okay. T is 6. Okay. Z is 2. y is 20. Okay, and now you might think that's all the variables, but there's certain variables that we haven't actually listed here. So all the ones here that aren't included in our basic variable must be equal to 0. So what have we got? We've got x equals to 0. We've got r equals to 0. And we've also got s equals to 0. So that, I think, is it. You do have to take a lot of care with these questions, not for the faint-hearted. If you use a calculator, just make sure you do the same thing every time. Watch out for double negatives, watch out for fractions, make sure you get your pivot row right, make sure you're going back to each one. Some people are better at it than others. I think you might have actually recognised that. Myself, I'm not actually that good at this. It's easy to look at the wrong numbers. Okay, so if this video has shown anything, hopefully it's helped. So it helps give you an idea of what to do, but it also gives you an idea that even pretty good mathematicians, in fact, perhaps especially pretty good mathematicians, can screw this up big style on occasion. So take care, folks. I hope you enjoyed it. There's nothing like a bit of linear programming, simple method. It is pretty good maths really when it comes down to it. I hope you agree. Bye.